All right, so now what we're going to do is we are going to write formulas, complete and net ionic equations. So there are three forms of an equation. There is the formula equation, which are the balanced equations, which include all reactants and products with their chemical formulas as well as their states. And then we're going to have complete ionic equations, which show all the soluble ionic species broken into their respective ions. So for example, if you had aqueous potassium iodide, so two potassium iodides is actually two potassium ions and two iodine ions in solution. Same thing with the aqueous lead nitrate. So it's going to be Pb2 plus, and then the subscript on the nitrate means that there's two nitrate ions forming this solid, which you would not break up into ions because it's not ionic. It is solid, precipitated out of reaction. And then you'd have the aqueous solution at the end here, which is your two potassiums and your two nitrate ions. Then the last form of an equation is called the net ionic equation, which shows only the species that are actually involved in the reaction. So if you remember from Chem 50, there's like certain things that can drive a chemical reaction, and one of them is the formation of a solid. So this reaction, if it didn't form a solid, it didn't actually happen, right? It would just be a whole bunch of ions floating around in solution, and you'd be like, oh, well, nothing really happened. Whereas the formation of this solid is what's driving a reaction to have occurred. So the net ionic equation would show the species that are actively involved in the reaction, and we omit what we call the spectator ions, so the things that are doing nothing. So for example, if you look here, you've got potassium on the right, you've got potassium on the left, you've got nitrate on the right, you've got nitrate on the left. So the only ions involved in the reaction are the lead and the iodine ions. So you'd have lead 2 plus aqueous plus 2 iodine ions. Aqueous forms this lead. I was like looking below, I'm like, right, this is lead 2 nitrate. It's a type 2 naming. Okay, so for the combination of lead nitrate and iron 3 chloride, we want to identify the possible products by formula. So we're going to write the formula equation. Then we're going to state which, if any, of the products has low solubility. So we're going to put in their states. And then if there is a precipitate, we're going to write the formula equation, the total net ionic equation, or total ionic equation, and the net ionic just for practice. So I kind of do like A, B, and C all together for the first part. So if we have lead 2 nitrate mixing with iron 3 chloride, they're telling us that they're both aqueous solutions. So how do we write their formulas? Well, lead is Pb2 plus. So nitrate is 1 minus. So we're going to go lead nitrate with a 2. This is going to be aqueous. Plus, we're going to have iron 3 chloride. So you're going to have iron 3 plus. Chloride is 1 minus. So it's going to be FeCl3 aqueous. And then what are my potential products? Well, my potential products are lead chloride. So lead chloride. So the lead was 2 plus. So now the Cl2. And iron nitrate. So it's going to be iron nitrate with a 3. So the next thing we'd want to do is balance this equation. So where do we want to start? Well, I usually start with the metals, but my metals are all balanced. We've got lead, iron, everything's good. So really what we have to do is balance the chlorides and balance the nitrates. So if I look at this, I've got 3 chlorides on the left and 2 on the right. So I'm going to make this 6. So I'm going to put a 2 and a 3. And then same thing with the nitrates. I have 2 on the left and I have 3 on the right, so I'm going to make them 6. So I'm going to put a 2 there, and I'm going to put a 3 there, and then you just double check. Lead is 3, lead is 3. Iron's 2, iron's 2. All right, so now that we've written the formula equation, we have to make sure we include the states. Now, if neither of these forms a solid, then this actually isn't a reaction that occurred, but let's look it up. So let's look at lead 2 chloride first. So we're going to look at the chloride ions. Chloride with everything but silver, lead, and copper is soluble. So chloride with lead is low solubility, meaning this is going to form a solid. And then this one I knew wouldn't because it was with nitrate, so it's going to be aqueous. Awesome. So because this did form a precipitate, we can write the total ionic equation and the net ionic equation. Now, oftentimes you can skip the total ionic equation and go right to the net ionic, and it's a lot easier, but we are going to practice writing total ionic equations, which means we're going to break every aqueous species up into its ions. So we're going to start with 3 lead, 2 plus aqueous. And then for the nitrate, you have subscript 2 and coefficient 3. So you have 6 nitrate aqueous. Then the iron, you have 2 iron 3 plus aqueous plus 6 chloride aqueous forms 3 PbCl2, because you can't break up a solid into its ions. And then you have 2 iron 3 plus aqueous plus 6 nitrate minus aqueous. So that's my total ionic equation. And then lastly, I'm going to write the net ionic. So the net ionic is going to be the only things that are actually involved in driving the reaction, which is going to be the formation of this solid. So the formation of the solid comes from these 3 lead ions and the 6 chloride ions. Everything else is a spectator. So the nitrate left and right, the irons left and right. It's really good to double check that everything's balanced, that they do cancel out, like 2 with 2 and 6 with 6. But then I'm going to write my net ionic equation is going to be just 3 Pb2 plus aqueous plus the 6 Cl minus aqueous forms the 3 PbCl2 solid. So we've got our formula equation, our total ionic equation, and our net ionic equation. Awesome. Okay, go practice doing those.